गुड मॉर्निंग एवरीवन। सॉरी, थोड़ा सा टेक्निकल एरर की वजह से अभी ज्वाइन नहीं कर पा रहे हैं। अभी बस विद इन मिनट ऑन कर रहे हैं।
Okay. Now you can hear me, na? Now what I have to do? 35 participants इसमें शो करने लग गया 36. Can it be made full screen, please?
नाउ स्क्रीन इज विजिबल सर।
Screen I can see, but is it coming in full screen or not?
नाउ इज ओके।
I can see you, I can see my PPT, but how I will run it मुझे नहीं समझ में आ रहा है.
इसे प्ले मैं कर दूंगा, डोंट वरी।
अच्छा, okay, I'll keep saying next करके ना.
यस यस यस।
मैंने वीडियो बंद किया है, ऑडियो इज ऑन.
गुड मॉर्निंग एवरीवन। सॉरी फॉर डिले because of we have some technical error. और आज के हमारे स्पीकर हैं इंजीनियर एम मेहरोत्रा। इंजीनियर मेहरोत्रा retired on 31st October 2024 from the military engineer services as chief engineer, joint director general works at army headquarters, bring over 35 plus years of distinguished experience in electrical, mechanical, and civil engineering. He did his BTech in electrical engineering from GB Pant University of Agriculture and Technology. He did MTech in power system engineering from IIT Kharagpur. He has also done PG diploma in public policy and management from MDI Gurugram. His expertise expands the planning and execution of complex infrastructure projects, including residential complexes, power distribution systems, solar energy installation, power supply, and sewage installations, runways, ports, and hospitals, reflecting a career dedicated to delivering large-scale mission critical facilities with technical and managerial experience. Now, request to the engineer Mehrotra, please take over.
Hi everyone, can you all see my presentation over here?
Yes, sir. Yes, sir. We can see.
Yes. So, gentlemen, uh, as I see, there are 36 participants in this. So, I welcome you all on behalf of Engineering Council of India. Last time when I delivered my presentation, somebody had asked for uh, some present discussion on IBMS systems. So I was trying to prepare that, but then there were some technical issues. So instead of that, I am sharing with you some very practical and relevant topic. This is maintenance problems with MEP services of a residential complex. This is encountered by any E&M engineer working anywhere. Next is, this is the list of services which is generally covered in this. This is not important. First, when we are there, whether it's a township, whether it's a multi-storied building or anything, first is we get supply from state electricity board system. So you can see on the right, there is an HT supply coming. That supply will first come into HT metering kiosk. So metering is the first thing which is there. Before that, there is only a cut point in the form of GOD or load break switch. One important thing I want to tell, load break switch should not be confused with VCB or circuit breaker. Load break switch is only to switch the normal load currents. It is not, doesn't have short circuit handling capacity. Now from HT metering, it will come to HT panels. HT panels will, one of the outgoing will go to transformer. Transformer output will come to LT panels. Then there is further distribution boards and lighting fan circuit. So this is in short what is there. There is one thing, APFC panel. APFC panel I have introduced little later. The thing is, this power factor improvement has been made mandatory by all electricity board and electricity authorities. So as you know, better the power factor, better the efficiency of supply system. Otherwise, mm, if I tell 100 kilowatt is the real power. If I see a rolling mill, that it is rolling steel, so it is creating some real power, but apparent there is some energy which is required to be given by the system because of presence of transformer and other things. So that will be little more. So if this power factor should be as close to 1 as possible, then power utilized and power provided by the system will be the same. Next is This schematic diagram drawing, every power system engineer must know and must possess whatever area he is looking after. Today, we will be more covering the maintenance aspect rather than the theoretical ones. Now, this is the sketch of an earthing. Earthing, why I have put this, earthing is a very common elementary thing. But what is there in earthing is not down below you can see there is a plate. So somebody will say copper plate, somebody will say iron plate and all those things. Those things are also required. Somebody will say chemical earthing. But what is the real earthing is the cylindrical shape around this plate, which is responsible for dissipating energy into the earth. Now here the plate may be of gold, but if the earth around is dry and non-conducting, this energy will not dissipate into ground. For that, that media is important. How that media is created? Layers of coal, salt, and earth. So that makes it. Other than that, there are some chemical earthing and other things which retain moisture in the media. So better the moisture content in the media, better is the fault dissipation. Now, transformers are the backbone of a supply system. Normally, a transformer should never burn, never ever burn. It 25 years, 50 years, it should keep working if it has been properly maintained and used within its parameters. Nothing happens in transformer. Only some preventive maintenance and other things are required, which is to be done. So this, as a power system engineer, one should ensure there is no failure of transformer in your area. Transformer failure happens because of overloading, insulation failure, oil leakage or contamination, moisture ingress, overheating, poor ventilation, short circuits, and electrical surges, lack of regular maintenance. Now overloading, आप बोलोगे ट्रांसफॉर्मर तो मैंने 500 kVA का लगाया हुआ है, but why it is overloading? My total load is less than 500 kVA, so I should say my transformer is not overloaded. But loading is pertaining to each phase. If suppose, for example, a transformer is 600 kVA, each phase will see 200, 200, 200 kVA each. Now, if one of the phase is loaded to 250 kVA, other one is loaded to 150 kVA, third one is loaded to 200 kVA. Now it is not balanced, means one phase is overloaded. So some cushion is always provided by the manufacturer. It will take that much of load. Now you have to imagine three-phase transformer into a combination of three single-phase transformers. Suppose one phase is overloaded by 100%. This transformer can burn anytime while other two phases are intact. Then next is insulation failure. Insulation failure, most common the transformers used are oil filled. Insulation failure will occur when there is moisture inside it or there are carbon particles inside the tank. Now what will happen? It will increase the conductivity of the medium. Normally this oil is such that it has got better dielectric strength, around 50 kV per centimeter. So if that dielectric strength is maintained, nothing will happen, no short circuit, nothing. Now oil leakage or contamination, oil is providing two services. One is it is providing the insulation. Second, it is also providing heat dissipation. So if the oil is leaking, then the level of oil will come down from transformer. So this heat carrying capacity will reduce. Moisture ingress, it is clear that transformer should be airtight. It should not allow any moisture to enter inside. There is always a silica gel bottle provided over there, which gives an indication whether the transformer has received some moisture, or oil has got higher level of moisture. Now, overheating is, there is a gauge given over there outside. Nowadays, all this data is going into a uh, digital system called SCADA or BMS, Building Management System, where it is reflected what is the load, how much is the temperature. So all those things are to be monitored. Otherwise, in the physical system, people will not go to different places and take the reading. Ventilation, wherever transformer is kept, suppose it is outside, there is ventilation is not an issue, but indoor substation ventilation is a big issue. Short circuits and electrical surges, it happens if your protective system is not working properly. It may lead to transformer failure also. Lack of regular maintenance needs no explanation. Now, how you will judge my transformer is getting overloaded? Unusual temperature rise, reduced efficiency, frequent tripping, insulation deterioration, abnormal humming sound. Means these things are telltale signs you will see and you will find these are the problems. My transformer is getting degraded. Now, what you should do? You should monitor your load regularly and avoid sudden load fluctuations. Suppose in one of the phases, you provide a load in such a manner that one complete phase is nearly comes down to about 20% of the load. So that is there. So load fluctuation should not be allowed much. Load management system is very important. When you distribute the power, it is either in the form of overhead lines or in the form of underground cables. So overhead lines, by suitably altering the jumpers, you can reach the uniformity of load. In case of underground cables, that same thing can be done in the feeder pillar box, where that these jumpers can change, phases can be changed. Now, capacity, I'll come this, there is a slide on this. It will come, what is the capacity to which this transformer should be loaded. Now, what happens when the oil leaks? Cooling is poor, temperature will increase, chances of insulation failure will be there. Transformer, moisture is there in the transformer, and environmental hazard means a reptile can enter inside the transformer. There should not be any open point available for these things. Now, transformer is always located somewhere at far away, but it is the heart of our complete supply system. If it fails, then restoration of power is not quick. Sometimes it takes even 1 month if the failure has happened in your main HT transformer. Now, if there are so much of problems with oil type transformer, then what will happen with the my closed spaces, my cinema halls, my hospitals and other things where there is no space outside? Then we'll use dry type transformer. Here the insulation is provided, while windings are covered in dry insulation. So what is there? There is some compromise in heat taking capacity, carrying capacity. It is costlier also, but that there is no alternative but to keep it in underground in the multi-storied buildings, in the basements. You provide transformers where you provide dry type transformers. So the question is, are dry type transformers more reliable? They will not see frequent faults, as they don't require filtration of oil and other things. But if at the same time they are costly and they will require more ventilation system in the basements, which is generally not available. What are the common issues with dry type transformer? Presence of dust, ventilation, blockages of overheating of coil, wear and tear of insulation. If there is dust in your underground area, dust will settle on these. That will capture moisture. So these things reduce the insulating capability of the transformer. Next is what should be the best way to prevent this? Is maintain a clear pathway, provide sufficient air circulation to perform regular heat inspection. These generally transformer is a forgotten entity, whereas at, uh, if not possible every day, but every week or 15 days, all these parameters should be checked and noted and recorded so that when next reading you take, you have something to compare. So, in case of power system maintenance, recording of parameters is very important. Now, overall, if I come to transformer, what is my effective strategy? Routine visual inspections, thermal monitoring, oil quality testing. What should be the in case of oil field transformer? What should be the oil rating? 50 kV per centimeter. This is what IS says. Insulation resistance testing, cleaning and tightening of connections. So these things are known. Now now I'll come to VCB. VCB, you must have seen normal air circuit breaker. Mechanism to close is similar, but contact here is kept inside a vacuum bottle. Glass bottle is there, inside there is vacuum. When there is hardly any media, no spark takes place over there. So what will happen in case of VCB? Vacuum, suppose there because of prolonged trippings, inside vacuum has disturbed. So there will be problem of failure. Then spring mechanism in any inside it is very small 4 mm or 5 mm gap, but this gap is filled through a strong spring mechanism which is required to be checked. Transient over voltages, incorrect trip settings. Achha, now incorrect trip settings is there is one thing which I want to tell. Fault isolation. Fault isolation depends on the relay setting. Suppose the relay is actually the brain of a circuit breaker. Circuit breaker in itself is nothing. So you need to have a battery bank which provides supply to relay. Relay senses the current. When there is overcurrent, it will send signal to transformer, whether it's a overload or a short circuit. Accordingly, the system trips. Relay itself doesn't have any tripping mechanism, but it senses the current and sends signal to the tripping coil. So that makes it trip or otherwise. It can happen if relay setting is not proper. You consider your source. I had shown you that overhead line which was coming. So that is your source. At that location, meter location, whatever my circuit breaker is there, it should trip at the last. First, it should trip in the MCB in my house, then the MCCB in the panel, then the outgoing OCB, then incoming OCB, VCB, and then the beyond metering panel is SCB circuit breaker. So there has to be a proper gradation in terms of time required for each this thing. Generally, experts they come with a laptop and set it is artificially without giving actual load. these relays can be made to trip. Now next is 80% rule and 125% rule. If I have a transformer of 500 kVA, the total load on it will never exceed 400 kVA. Suppose it will 500 kVA also it will bear, but if it is more than 3 hours or longer, slowly heat will be there. Yes, anybody wanted to know anything? Okay, I'll proceed. Then there is reciprocal of this, which is 125% rule. Means if my load is 400 kVA, the transformer I will put 500 kVA. So this is up. You must have seen your plug point at in your home where you must be using press or other things. Though the power point is of 10 ampere, the current through that power point never goes to that rating. But over a period of time, you will find that power point has burnt. It has burnt because that cushion is not available to the power point. MCCBs, MCCBs is nuisance tripping, overheating terminals, internal component aging is the problem with MCCB. Now I'll come to DG set. DG set, I had shown you a figure of earthing. So earthing is important for any power system, whether it is a transformer or it's a DG set. Now, any DG set or transformer will require 4 earthings, 2 for body, 2 for neutral. One important thing is that distance of earth in between each other and from the building. From the building, any earth should be at least 4 feet away, and two adjacent earthings should not be less than 8 feet away. So why this condition is there? As I had told you, the fault current, that energy tries to dissipate horizontally into the ground. If two earthings are close by, then there will be a short circuit between two earthings.
Damdar?
Yes.
Oh, sorry.
Okay. Now you have installed a DG set. DG set can be single, can be two pieces depending upon the requirement. But you should never run it parallel with the SEB supply. If there are two DG sets, they will run parallel with each other. Suppose the load in the system is 1000 kVA and you run two DG sets of 500 kVA. So they can be made to run parallel, but definitely not one side you provide with SEB supply and one side with DG set supply, because then there is a frequency mismatch. It can create havoc. Now, nowadays DG sets are all come in a enclosure like this. So, but still ventilation is very crucial. If this enclosure is kept in outside in the open, then ventilation is not very critical. But here there should be sufficient uh, ventilation, exhaust fan, and other things. So these things are important. Then this DG set container should be kept on a concrete ground, rigid, about 10 to 12 inches high. Now, when the new DG set comes, you do the load testing. I hope everybody is aware of the KW and KVA considerations. Now, when you order it, you ask your vendor to bring the load. Load it is normally a resistive load where they put water load. So it is a resistive one. So you may say that my DG set is 500 kVA. So I will test it with a load of 500 kilowatt because my power factor is 1. But that is not the case, because then there is a rating of DG set, where you will see that rating, you will see that power factor 0.8 is written over there. So DG set inside the alternator is actually an inductive machine. It will have some inherent power factor. So real power is 400 kilowatt. Real power is something, a rolling mill is there, so actual work which is being done is that real power, but the apparent power will be more. So load, you will put only 400 kilowatt, whether if suppose the vendor brings an inductive load, then it will be 500 kVA, otherwise 400 kilowatt is okay. Then I have put the word RECD. What is RECD? Re- residu- Residual emission control device. As in case of vehicles, you will find that hold on. You will find that vehicles, that Bharat stage 6, Bharat stage 5, Bharat stage 4 and other things will, they keep coming. But these factories which make generators, they will not change their manufacturing system quickly. So what is there? So what that government allows some time to them, but then they have to put a gadget which is called RECD. It is provided with the exhaust. So this will make sure, just like your vehicle exhaust, they put here, they will put some additional facility, and they will make sure that pollution which is going into the atmosphere is well within the limit. So there are some standard manufacturers which have been allowed by BIS. Only those manufacturers RECD should be provided. Now DG set, when you are installing, there are, it is if the earthing is not proper, then it can lead to electrical shocks, equipment damage, fire hazards due to improper fault current discharge. Fault current discharge into the ground is very, very important. Ventilation needs no further explanation. Fuel system is important. Fuel system should not leak, otherwise it can lead to fire hazards, and it can lead to other problems. Electrical connection errors, loose, undersized, or poorly insulated wiring can cause overheating, short circuit, and potential fire hazards. This is what ventilation I was talking. Ventilation is important. Whatever heat is being dissipated by your DG set, it should quickly go away. Now, this DG set is inside and actually inside an enclosure, and it is my exhaust system is taking care of heat dissipation. Now, next is internal electric supply, that is your wiring, etc. Now, uh, you see the how important that wiring is. It may look harmless, but it is most troublesome for a MEP engineer. So when the building is being made, you all know that MEP services are the uh, spirit of living in that body. Okay. So without MEP services, that building is of no use. Now, uh, normally when the building is started getting made, that time your civil engineers are in full form. So they will, but that time an MEP engineer, electrical person should go and see the location of uh, mm, fan hook and other things in the reinforcement. What happens? you imagine a building is being constructed. There are props all over. Partition walls are not there, so you do not know. But drawing shows location of fan and light point correctly. So whether that location is correct or not, because what will happen later, partition walls will come. You will find I have seen my fan hook provided just about 40 centimeter away from the wall. Because that was good old time when drawings were made by hand, by pencil. So one had put, because the person who is doing this is not a learned one, he is not a literate one. He will, whatever is there, you have to see, because marking of fans and light points can have errors. That has to be seen by the MEP engineer during slab casting stage. Now, suppose it's a house. Normally, one house is provided by one phase, and next house will go to other phase. Third house will go to next phase. Why this three phases distribution is there? One is we need to provide three phase only where we need some rotational machine, motor, something like motor. So we have got some motors which run on single phase, like fan, your mixer, your other things. So there it is okay, but load balancing is required. So if one phase is R, next phase should be Y, next phase should be B, like that. Then now every house will have power wiring and light fan wiring. Power wiring, the conductor size is different. Light size wiring, conductor size is different. IS says the size of phase conductor will be 1.5 square mm. Same way, neutral conductor will be 1.5 square mm. Earthing will be half the size. Half the size means 1.5, half is 0.75. But IS also says no conductor should be less than 1.5. That means in my PowerPoint, light point, all the conductors will be of 1.5 square mm. So your 16 ampere power point will be fed from 2.5 mm cable. Now this is a limitation of how many wires are allowed to pass through the same conduit. Same conduit should not carry wires meant for different phases. This is very clear. Color coding. Color coding, I will show you a sketch. Color coding is important because one house has been provided with red phase. The next house will be Y phase. This has to be done for equalization of load. Each circuit provided in internal wiring should be independent and should be efficiently earthed. Means my distribution board will have, suppose it's a 8-way DB. I'll show you. This is an 8-way DB where there are 8 circuits coming out of it. That red color is 8 circuits, black color is neutral, and green color is earth. Like now number 1 is suppose one circuit. It goes to different part of my house where some light, some fan, some power point will be connected. But then there is a limitation how many points, some 8 points or whatever is possible to be loaded in one circuit. So this is different circuits. Now you see this sketch. There are 8 phase conductors, there are 8 neutral conductors, there are 8 earth conductors. So each conductor number will be same as that of number of circuits. What happens when the building is being constructed? The electrician is doing the wiring. What it does, phase or especially in neutral, the electrician has got tendency to, suppose he reaches one end of the room and next circuit is somewhere close by. What he will do, that neutral, it will connect from this room to that room, which is should not be done, because from my distribution board, that's independent system should come. Same thing is for earthing. Earthing is very important, because if earthing is not independent, it will create havoc. RCCB, now when the wiring is done, you check the wire for continuity, insulation test, and polarity test. What is polarity test? Means my switch should be in phase conductor only, not in neutral conductor. Suppose I provide the switch in neutral conductor, so light will still be off, but it is dangerous because phase is directly connected all the time. So polarity is important. That switch has to be only in phase conductor. This figure is showing how the wiring of a distribution board should be done. So everything is done very neatly. There are thimbles, but they have gone inside these holes. So there is nothing outside which can cause any short circuit. And even if some reptile comes, it will not cause any problem. This I have already explained. Next is what will happen, suppose my neutral is not properly connected. So what will happen? The point in the center between the two sources will not be at same potential. It has to be at zero potential. Actually, neutral is at zero potential. It will not happen. It will shift. So what will happen? There will be sparking. The lamp will brighten and uh, dim. Alternatively, your refrigerator can burn. So that loose neutral wire is very, very important to be checked. If my neutral wire is loose, I may get electric shocks. If an earthing system relies on a solid neutral, like in many multi-wire branch circuits, losing that connection can force earth rods and the metal chassis of earth appliances to become live, leading to dangerous shocks. So if earthing is not proper, that body of the gadget can become live. Otherwise, even if some leakage is there, earthing system is working properly. So it will take the dangerous voltages away from the body. Then overheating and fire hazards, high resistance at loose terminal or connection points lead to localized heating. You see that sparking and other things. This will burn your gadget also. This can melt wire insulation, cause dangerous arcing, and spark an electric fire. Now, there are appliances which may not properly work. They may become dead. Some appliances may stop turning on completely due to low voltage. While motors in devices like refrigerator or AC unit may burn out. This is neutral wire being intact is very, very important. Generally, you will find all the burning is there in neutral conductor only. Now, neutral conductor will be of what size? Single phase neutral and three phase neutral, there is a difference. Single phase neutral will be of the same size as that of phase conductor. Three phase circuit neutral will be half the size of the main conductor. Why half the size? Because generally these phases are connected in star pattern. Star where neutral is connected one end of the winding. Now, ideally, this it should pass no current if the three currents are equal. There will be no current through the neutral wire. But if there is unbalance of load, some current will pass, which should be normally in the order of not more than 20-30%. That is why 50% conductor size is sufficient. But that sometimes the unbalance is more. That is why recording of load frequent in recording of load is important. Then there are, when the neutral connection breaks, power finds alternate return path through other connected load. As I had shown this, suppose neutral is not properly connected in from table lamp side, so still it will get return path through refrigerator. So when these finds, so there will be problem. Voltages imbalance will be there. This causes some severe voltage imbalances, and some outlets may only provide 70 volt, whereas others will spike to 200 volt. So this is a US system where supply system is 110 volt. So 200 volt is dangerous over there. In our case, 200 volt is good enough. Lights flickering or changing brightness. A telltale sign of loose neutral is lights dimming severely when I am giving these points to you so that you can keep a note, and these things are, if problem is happening, so you can tell your staff if this thing is happening, please go and check this. Now, fire alarm system. What is a fire alarm? Fire alarm system, as you might have seen in any building, fire alarm system doesn't fight with fire, but it tells you there is fire. So there will be heat detectors, there will be smoke detectors. These break glass in case of fire. These press these switches you must have seen elsewhere. Now this fire alarm system is fed from a battery supply. So it is independent of your normal power supply which is there in the building. So it has to be fed from a battery, independent battery. So what now there is a control panel which gets power from electric power supply. It is not your SEB supply. It is definitely your UPS or something like that. Now control panel will receive signals from smoke detectors and heat detectors. They are provided in the building just like light point and fan point. Wiring system is similar, but instead of taking power from source to that termination, here a signal is coming from that termination to this control panel. Control panel is responsible for sending power to this. If it detects, it will send a signal over here in the control panel. Control panel will immediately tell the hooters and sounders that there is some fire. So people will get to know that some emergency has been created. Now, then there are some communicating devices. Means what happens? Suppose there is fire in a building. So first thing is an outsider who is coming to fight the fire should know where the fire is. So where the fire is will be known by repeater panel. So if I go back, this is old system where each circuit was reflected by an LED. So this will tell you where my fire is. Now, when there but building will have diff, architecture different. But here, suppose I have provided 20 detectors. 20 detectors are provided at some location. So my control panel will only know that out of 20, 16 number has activated. But where this 16 number is there will be known through these panels. Panels there is something called mimic panel, there is something called repeater panel. And this mimic panel is inside the building where it shows different wings and floors where there these things will be marked. So you will come to know that east wing, third floor, there is fire. Repeater panel is provided at the the gate security. They will immediately tell building number 6, floor, third floor, there is fire. So run towards that. Earlier, these panels which were there, now these have become obsolete. Detectors are same as it were there, but they have far more improved now. Now there is a computer screen provided over there. It tells us where the location of fire instantaneously. So what are the problems in case? But most nuisance is this fire alarm cause false alarms. Why these happen? They are caused by dust accumulation. This is actually fire alarm system is a neglected facility which keeps giving nuisance problems, but its utility is known when there is fire. They make sure the fire is remain localized. You must have heard that where children studying in a coaching institute got burnt alive. So there, if the alarm is there, they will immediately run before dangerous temperatures are reached. So why a false accumulate that detector will give false alarm? Dust accumulation, insect infestation, humidity, or smoke from cooking. Some time back, where I stay in Delhi, in the kitchen chimney there was uh, oil leakage was there. So this oil caught fire. So within minutes, this fire got spread to different rooms and other things. Before people could reach, the fire had already come to some unmanageable levels. First, then firefighting system took over, and it was no damage was done. So these detectors which we saw in previous slide should be cleaned and vacuumed regularly. This is you have to engage an agency which does this and keeps a record when which one was done, maintained properly. Beeping or chirping warning that backup batteries are low or expired. Means, as I told, this fire alarm system will be fed from UPS or a battery bank. If the as you in case of your torch, if the cell is low, so what will happen? It will glow, paint. It will have paint glow, something like that. So replace batteries immediately and verify the recommended type for your unit. Wiring and ground fault, unintentional wire contact with metal, open circuits, or damaged cables can disable devices and trigger system trouble. So why that these things are important? You have to see that no wire or conducting part should be touching over there. Inspect connections and seek a professional fire safety technician. The thing is, no, your normal electrician should never touch these detectors, this fire alarm system, because it has to be handled by a professional. Suppose sensor malfunctions, most manufacturers recommend detector replacement after every 10 years. Means you have to replace whether it is still working or not. After 10 years, you must replace your detector. You will come to know only through if the record is maintained properly. Maintenance system requires good maintenance of records. Now, air conditioning and ventilation, here I am not talking of a central AC plant or package AC plant, but you consider it can be a township, it can be a multi-storied building where generally split AC or window ACs are being used. So, because if I start taking these AC plants, then it's a big engineering in itself. For that, time is will not be sufficient. Now, whenever ACs are put, at least you must put at least 4-star AC. Now, nowadays, nobody should be allowed to use 3-star AC because efficiency is low. It will heat your wiring system more. Now, there's a split AC. You think of a split AC, where the split unit is provided in the balcony, where it is, and inside your uh, evaporator is there, where fan is there, and room is being cooled. Now, it is important to know that supply is coming from a distribution board, DB. First, DB may be close to your indoor unit, but first the supply will go from DB to outside unit. From outside unit, one wire without any joints will come to your indoor unit. What will happen? And normal wiring wire size is 1.5 square mm. There may be a tendency in the electrician here, cost saving is not much, but the electrician may use the same uh, conductor which he is using for wiring, light fan wiring, for this split AC. uh, and one is it is a bigger machine, so 2.5 square mm size is minimum, and it should not have joint. Sometimes it happens because the mm, in one of the cases I have seen that it around 10-15 meter was the distance from outdoor unit to inside unit. Up to 8 meter tight wire was 2.5 square mm, but then there was a joint through tape, and 1.5 square mm was coming up to the indoor unit. Now, if you test it, it will run, but it will not run for a long duration. After some time, it will start tripping. Then from outdoor unit, refrigerant piping is your copper pipe. Copper pipe is prone to damages, so it should be insulated and protected. So that both the things are important. Now it's a ventilation system for a multi-storied building. This is the parking. It can be in any mall. It can be any residential complex. So when you see a AC system of a building, there are ductings. These are also same way ductings. Why this ducting is coming close to floor level? Because it is parking, so that fumes from the vehicles will get sucked away quickly. So now, as in case of desert cooler, this is being thrown away from the building through these large axial fans. It's something called jet fans. You cannot providing ducting to large areas, so you provide jet fans. You must have seen these days lot of tunnels are being made by highway authority. In tunnels, such fans are there, so they will channelize air through this, and so it doesn't will not require ducting. So cost saving will be there. Then there are some systems where you provide impeller just like your uh, kitchen chimney. Their impeller is similar. So it is something like that. Basically, it is throwing away air at 90-degree angle from where it is coming. Next is your lift. Lifts are two types, passenger lift and goods lift. They are machine-wise, they are same. It is only the load carrying capacity and shape which is different in case of passenger lift and goods lift. I have used a word called dumb waiter. Dumb waiter is provided in case of medical stores, shops, or in restaurants. Here, the person will not travel, but some item will move from one level to other level. That is why it is called dumb waiter. Passenger lift, goods lift is clear. Then speed is normally in India 1 meter per second, 1.5 meter per second is common. When the number of floors are more, then it can go up to 5 meters. When in very high buildings, the speeds are much higher than this, but then some mechanism is put so that you don't feel the effect of gravity if the lift is moving at a fast pace. Now, in your building, one lift must be designated as fire lift because fire lift will not be used by anybody else. If there is a fire in the building, all lifts will be switched off. That is why we tell the occupants, please move, rush through the staircase. In case of lift, it is made dead. And there is only one lift which is functional. It is directly connected to DG set supply. This is fireman will first see whether it is safe to use this lift or not. Then it will use that they will use this. Then inside there is intercom is a must. Suppose one get the lift suddenly stops, the person should not panic. One thing I want to tell you all, no lift until and unless there is free fall will cause any problem to the person which is inside. So what will happen? Suppose the lift is stopped suddenly, supply goes. Now first thing is lift will come to a halt. How it will come to halt? The braking system is released as long as there is supply in the system. The moment there is no supply, brake will automatically come into play and stop the lift then and there. So suppose you get trapped inside, what will happen? There is a communication system provided inside, and lift will is stopped. Its size and shape is such that if the door is opened by a helping staff, either you can go climb up or go down. So you will be rescued. Now, other thing, the one more safety gadget is automatic rescue device. Here, some power source, some battery bank, or some sources there in the machinery. Suppose supply has gone. So this will come into picture. This will release the brake for a short duration, and the moment floor landing sensor indicator tells, it will stop the lift immediately, so person can come out safely. In case of residential buildings, this lift stops at every floor whatever the command comes. But in case of shopping malls, airports, and other places, there the lift may stop only at specified floors. Where the rush is more, sometimes what happens that one common switch is there at the entrance. You put your suppose you want to go to fourth floor, it will glow. You go to lift number P4. So you go and stand in front of P4. That P4 will only stop in fourth floor. Other lift may be stopping at different. So here the crowd is more, so it will keep the crowd in check. Now, in case of every building, the moment lift door opens, you must see which floor it is. The floor signboard is important. Here, the role of MEP engineer is there. Either you force your civil engineering structural friends that there must be signboard provided right in front of lift car. Otherwise, make the part of that contract that they will provide the floor signboard also. Now, what will happen? What happens in case of lifts? In case of lifts, what happens? Doors may be malfunctioning. So what will happen? Doors failing to close, closing too quickly, or getting stuck. What what will happen? Why it is happening? It is all because of sensors. Sensors are misaligned. Door rollers are worn out. The tracks may be dirty, and safety switches may become damaged. These are the causes why this malfunctioning. This is the most common problem of any lift system which has become slightly old. These doors are malfunctioning. You have to be very careful about. So the regular cleaning of door seals. This looks harmless, but it is very important point. Lubrication of hangers and recalibration of photo eye sensors. You must be jutting out your hand. Suppose the door has started closing. So firstly, that hand jutting out should be avoided. These sensors are there, infrared rays. They will make sure if there is anybody in the entry point, it will not close. Slow, jerky or noisy movement, shaking sensation, unusual grinding, rattling, squeaking noises or slow operation. Now, lift is moving on guide rails. Suppose lubrication has become less, so this will make noise. Misaligned motor drives, worn out sleeves, and or steel ropes, or issues with the main motor. So these are the causes. Routine inspection must be done. If your lift is giving vibration, that means something is to be checked. So periodically, it has to be seen by trained lift attendants only. Never untrained person should touch the lift. So otherwise, if the maintenance is done properly, no machine will ever burn. Now leveling more than half inch level difference from the landing is not allowed. So these things are checked by the person. Installation inaccuracies, uneven rope wear, oil contamination in hydraulic system, or an incorrectly positioned leveling sensor switch. This will result in uneven leveling. So magnetic or optical sensors are responsible for stopping the lift at floor deck must be replaced. Control system failures, buttons failing to respond, correct floor display or elevator remaining unresponsive. This may be due to voltage fluctuations, and power supplies must be checked, circuit breakers must be cleared, and emergency stop is not engaged. That has to be ensured. Now, next entity is your lightning protection. Lightning protection, as you all know, lightning protections are always provided. Lightning has got a tendency to come to highest point. Now, if you see below 15 meter, no lightning protection is needed. Why? Because highest points will be trees. So if lightning comes from the sky, it will be caught by the trees first. So generally in single storied building up to 3-4 storied building, lightning protection is not provided. So that will be taken care of by protection system of nearby high building or trees. Here you see all the features in the building must be connected. These are wires. These are conductors, not wires, but strips, aluminum strips, 25 by 3 size. Then these vertical things are finials. Finials is the highest point. Here it is sharp, so charge density will increase over here. So lightning will will be attracted here. So it will, through this conductor system, it will go into the earth. This the dotted line is the floor level of the building, and this is below floor level, and it is going to earth. So all these things are interconnected, so that lightning happens. The energy should be taken into the ground in the fastest possible time. The thing is, if that this is a massive energy, lakhs of volts and very strong heat, so it will go in it wherever it will find any resistance, it will convert into heat, and it will burn that area. So earth is a good conductor, so earth every energy should be allowed to be dissipated into the earth. Here efficacy of that earth electrode is very important, which I had shown in previous slides. Now these are cones of protection. Now cones of protection will provide, you don't have to remember this, but why, if there is a nearby multi-story building, small buildings will not need any, small height buildings will not need any lightning protection, because they are covered by this, through these cones of protection. So they, suppose there is a small building over here, it is already getting covered, so there is no need to provide any additional lightning protection system over there. Now, like fire alarm system, there is a now in India there is not much emphasis is given to maintain that lightning protection system. But in eastern coast area where lightning occurs more frequently and more strongly, there these things are very important. I used to live at Vishakhapatnam. There lot of lightning used to be there. So it has to be seen. The Bible of a maintenance engineer is that inspection, whenever it is being done, it must be recorded. So like air termination must be checked for any physical damage, corrosion, missing fasteners, and any conductor that has been displaced by maintenance work. Now what happens? These things are provided on the rooftop. Somebody has repaired the water supply line or the roof waterproofing. So these, they will disturb and damage your lightning protection system. So if that system is not healthy, and God forbid lightning occurs, it will fall on the building system. So continuity of all the conductors is very important. Means one conductor will not keep continuing throughout the length, because there will definitely be joints somewhere. So that resistance should not be more than 0.2 wherever this bonding connection has been made. Now ground resistance will not be less than 10 ohm. With that, what we are showing here, this earthing resistance will not be less than 10 ohm. Otherwise, normally whatever earthings we provide, they provide 5 ohm. But in good media condition, moist media condition. So in case of substation, we provide some arrangement so that area around this thing remains moist. But in case of building, it will not happen that area should remain moist. Now there are two types of lightning protections which are in use. One is your normal finials, which take the energy into the ground. Second is there is some surge protection device which is provided. Surge protection device are some towers kind of structures, generally not used in normal buildings in India. Here in I am from defense, so DRDO had studied this and they said in India we don't need these SPD.
Lights are not visible.
What is not visible? Slide is not visible.
No.
Can you see this?
No, sir.
Just hold on. I think somebody has joined. I'll just wait. Hello. Hello. Can you hear me?
Hello.
Yes, sir.
Hello.
Yes, sir. We can hear you.
Actually, my presentation is almost over. These slides will be available on YouTube. So you can see over there. So with this, I am finishing. Okay.
Now we can see the
now presentation is
slide.
visible,
Now
sir.
we can see the slide, sir.
वो the basic material my material has also finished. I had planned it that way because now next speaker has to take over. So I am signing off. These things will be visible to you through the links you can see in YouTube. Only 4 slides were left where there are only some sketches, diagrams. Okay.
Okay, sir.
Okay, I'm leaving. Thank you so much for your patient hearing.
Thank you, sir, and thank you everyone for being here.
Sir, where we can get this video and the presentation, sir? Yogaraj, sir.
I will share, sir, by tomorrow.
Sir,
First half.
this is very helpful and we are using
I will
regular
share.
work
I will
purpose.
share. I will share in first half. In first half, sir.
Thank you, sir. Thank you so much, sir.
Thank you, everyone.